Was that enough for you guys to see what you did wrong for number 20? Okay, I need some help. Let's raise a hand, show of hands. How many of you are comfortable looking at a problem and identifying what to let you equal? That's our first checkpoint. The majority. Okay. How many of you get to the point where we let you equal something and find the do you part, but have trouble adjusting for what's left? Who are my people who are struggling with that step? Kind of, sometimes. Depends on the problem. Maybe? All right, so that was 20. So that helps me. At least you guys know what to let you equal. That's good. I don't know if I had another one worked out. All right, let's do, which other ones would you like to see worked out? 24. Oh, that was beautiful. Beautiful. Did you guys like the training wheels? Did you like being given what to let you equal? Was that for all of them? I'm trying to remember. Of all the ones I assigned. Oh, well, that's why. Stupid question. Sorry. Shouldn't have trouble with what to let you equal. They're telling you. Why did the 4? Squared times y cubed plus 2y dy. All right, now I'm not going to put the training wheels on this one. You've already seen it, but let's pretend that we're looking at it for the first time. You should look at it. The first thing you should do is say, I either recognize or I don't recognize the overarching derivative this came from. Well, what kind of function did it come from? A power, a trig, a quotient, a product? What kind of function? A power, right? Something, if we're looking at something squared, we're kind of thinking at this point it came from something cubed, correct? So we should start to ask ourselves, if we're going to let u equal this inside, y to the 4th plus 4, 4y squared plus 1, do I see the derivative somewhere else? 4y cubed, I see a y cubed. An 8y, I see a 2y. And that could be adjusted for. Any numbers can be adjusted for. So I didn't want to throw this on you yesterday, but today, do you remember when we did the chain rule? Some of you remember very well because you had a bunch of CRs on your quizzes, okay? Saying chain rule. All right. The derivative of f of g of x. Make me proud. Who's got this? The derivative of f of g of x. The definition of the chain rule. Come on, someone.
I'm going to guess f prime g of x times g prime of x.
Tyler, that was beautiful.
Yes.
That was, it just flowed off the tongue as well. Like you were ready for it. Okay. F prime of g of x times g prime of x. And our little saying as we went along was take the derivative of the outer function, f prime, leave the inside alone, g of x, times the derivative of the inner part, g prime of x. Yes? So guess what we're looking for? In these rules, aren't we kind of looking like, oh, like that? No. Aren't we kind of looking for this? Does anybody understand what I'm talking about? Do you see a composite function? Yeah, I see a derivative. I would probably call that g of x, like the inner part. This came from something cubed, right? We already said that. And then do we see a g prime of x over here? Do we see the derivative of the inside over here? Yes, it's like the chain rule in reverse, isn't it? That's what we're looking at. So what are we trying to do? We're trying to rewind it to get back to the f of g of x part of it. So this process we call u substitution. We're going to let u equal y to the fourth plus 4y squared plus 1. What's du? 4y cubed plus 8y dy. And then what's the next question we ask ourselves? You're helping me out today. You just gotta get your hands dirty. What's the next question we're asking ourselves? Okay. Yeah, I gotta see it. Does it match? Does it match the rest of our integrand? In other words, ready? Do I see the g prime of x dx else? Isn't this part right here, the 4y cubed plus 8y dy? Isn't that the rest of it, like that we're looking for? So, well, I want it to look like this. I want it to say 8 quantity y cubed plus 2y dy. Well, how can I make it look like that? Well, let's factor this and see what we can get. So du equals 4. Now, I'm not taking a y out, and I'll show you why. Y cubed plus 2y dy. I pulled a 4 out, and I got it to look kind of like this. But I don't want a 4 times a y cubed plus 2y dy. I want an 8. How can I turn this 4 into an 8? Multiply both sides by 2, right? So, times 2. It's supposed to be purple. Times 2. Times 2. And so 2 du is 8 times y cubed plus 2y dy. That's one option. I'm going to give you guys another option. And I know sometimes when you're given too many options, it's overwhelming. I'm not trying to do that. But I bet some people did this. I bet some people brought the 8 all the way out front and let it just roll for the whole time. Like, I'm just going to ignore the 8 because what happens with the constant and derivatives and antiderivative just goes along for the ride. You with me? So if you had a y cubed plus 2y dy, then you could have done a fourth. You could have divided by 4 on both sides, a fourth du. And what happens with the 1/4? It also goes out front and combines with the 8 and turns into a 2. Same thing. Do you see how there's a couple options there? Well, let's check. Everything in blue matches everything here. I'm ready for my substitution. I have an integral sign. I have a parentheses squared, and that inside we called u. Everything in blue turns into 2 du. You can put the 2 out front. You can put the 2 in here. It doesn't really matter. Are you good so far? I'm going to pause. What questions do you have? Nothing so far. Isn't this one of those processes you watch in math where it's like, it looks really easy when you do it, and then when I try to do it on mine, it's like falls apart, right? I get it. The more you see, the better you'll feel about it, right? Wendy, please ask a question.
I don't know how it just like. Just keep going. You might figure it out.
Sounds good. Stop me if you have a question. Antiderivative. Isn't it a simple power rule right now? because it's with respect to u. So add 1 to the exponent, divide by the new exponent. So we have a 2, but then we have a 1/3 u cubed plus c. So we have a 2/3 u cubed plus c. So we have a 2/3. Plug x's back in. What was u equal to? 4x. No, sorry. Y to the 4th plus 4y squared plus 1. Y to the 4th plus 4y squared plus 1. I said plug x's back in. This one was a function of y. So I teach math. I don't do letters. Variables are fine. All right. That's my final answer. Can you check it? You could. You could take the derivative, and it would be a chain rule. And you get back to where you started. Questions on that? I don't think I assigned any with bounds, did I? I'd like to practice another one of those in class today, and then I hope to have some time for you guys to do some practice problems on your own. So you can stop and say, I'm stuck. Let's talk. Let's help. Let's get this figured out. All right? Your next one, your next challenge, shall you choose to accept it? You don't have a choice. Is this one. I think. Hold on a second. We did this one, right? Yes. We did that one. We did that one. I think we're on. Yes, I think this is our next one.
Mr. Muslim.
Go for it. Caleb.
It's the last time we book.
How was it?
Except for you.
All right. I know you're not done. Decision time. Should we let you equal? Well, what are our choices? Let you equal tangent x, secant squared x, both. No, probably not those. Secant x. Isn't secant squared x really secant of x quantity squared? So another way to write this is tangent of x times secant of x squared dx. So here's what you should be running through your mind right now. If I let u equal secant x, what's the du going to be? Is it going to encompass the rest of the stuff in there? Or if I let u equal tangent of x, is it going to encompass the rest of the stuff in there? You got to know your derivative rules. What if you say secant squared x? What's the derivative of secant x squared? 2, leave the inside alone, subtract 1 from the exponent, times secant x tangent x. Ooh, that's ugly. That's ugly. Because if I let u equal this part right here, is my du tangent x dx? No, so don't pick secant squared x. That's actually the only one you couldn't pick. Okay? Good news. You can either pick tangent of x or secant x. Okay? Do you guys see what I'm talking about? Let's try. Who let's vote. How many of you would pick tangent of x? I think that's the most obvious one. Okay? It's not wrong if you did it the other way. Let's try it. You guys have to get your hands dirty on these. Just try them, and if it goes wrong, it's okay. All right? Let u equal tangent of x. What's du? What's the derivative of tangent of x with respect to x? Secant squared x dx. Do not forget that. Remember, I let you skip a step. This is technically the du dx step. This is the derivative of the u function with respect to x. But I let you multiply the dx over. Quick check. Ready? Here we go. If I let u equal tangent of x, is my du elsewhere in the problem? Well, look at that. That all is going to turn into a du. Let's do it a second way. Ready? I'm going to do this in green. What if I let u equal secant of x? Let u equal secant x. What's du? Secant x times tangent x dx. Well, I'm in green right now. I'm in green. I just took one of those secant x's and called it u. Isn't this integrand tangent x times secant x times secant x dx? Isn't that another way to write secant squared x? Guess what? If I call one of them u, isn't secant x tangent x dx du? See it? Kind of tricky. I think the red and blue are probably the most obvious ones for us. All right? We'll get rid of the screen for now. If you did it another way, that's fine. All right. So let's continue. My integrand is getting transformed. It was tangent x times secant squared x dx. Now it's, what's in red? I let u equal tangent x. U. Everything in blue turns into du. That's a pretty simple integrand. What are my bounds? They were x bounds. Now they are u bounds. Where do I plug the x's in to find out what they convert into to become u's? Into the u function. U equals tangent of x. What's the tangent of 0? Well, it's the sine of 0 over the cosine of 0. 0. So when x equals 0, u also equals 0. U equals 0. When x is pi over 3, u is going to be the u equals tangent of pi over 3, which is the sine of pi over 3 over the cosine of pi over 3. A quick sketch will remind us how wonderful we are at the unit circle. What's this point up here at pi over 3? 1/2, comma, radical 3 over 2. Remember how we had this talk already? It's higher than it is over because it's a 60-degree angle. Higher, radical 3 over 2. Over 1/2. Well, I'm going to divide those two because I'm doing tangent. Radical 3 over 2 divided by 1/2. Keep, change, flip. Times 2 over 1. Radical 3. So when x is pi over 3, u equals radical 3. How beautiful. How beautiful. Anti-differentiation time. What's the antiderivative of u? This is an easy question, but I cringe because I'm concerned with what's going to happen. 1/2 u squared. 1/2 u squared.
1/2 u squared plus
Thank you.
c.
Plus a constant. Yes. But you guys all see it's 1/2 u squared plus c. I'm getting blank looks. I don't know if that's just your normal phrase or just add one to. Isn't it a power rule? It's with respect to u, so add 1 to the exponent. Divide by the new exponent. 1/2 u squared. That's a cube. U squared plus a constant from 0 to radical 3. I'm going to pause again. I have students all the time who are like, well, every time we did an indefinite integral, we always plugged x's back in. So I'm going to go back to x's. And they take u and they put a tangent of x, and they have 1/2 tangent x squared plus c, and then they change the bounds back to 0 and pi over 3 because they went back to x's. Don't do it. Okay? You just made this problem a lot easier on yourself by switching to u's. Wasn't that an easy antiderivative, right? Finish it off with u's. It's going to be, your answer is going to be a number. All right. 1/2 radical 3 squared plus a constant minus 1/2 0 squared plus a constant. What's radical 3 squared? 3 over 2. 3/2. Isn't that beautiful? That is beautiful. Unexpected. I mean, think about it. You've got tangent of x times secant squared x from 0 to pi over 3, and it's a perfect 3/2, 1.5 area. You guys aren't thinking it's as beautiful as I do. It's okay. I think I have the right answer up here. Yes. I still get excited. It's the Khan Academy effect. Got it. You did 20. Did I have you guys do this one? We did one similar. Let's do this one. That's from 0 to 2. For those of you visually impaired, integral from 0 to 2 of x over x squared minus 9 dx. If you're stuck, we did one just like it yesterday. Might have been like an x squared plus 1 or something like that in the denominator. Yeah. Plus 4. Now, if you're doing these tonight and you're stuck and you're like, it's an even number, I want to see if I got the right answer. You can type that in your calculator. It'll give you the answer. Like, it'll give you the number, the numerical area. It's kind of nice. You can just check and see if you got it right. That's what Slater. Again? Huh? Jason Slater. You probably didn't have the privilege of watching Saved by the Bell, did you? Screech. Do you guys use Slater to watch, like, to check?
What?
I don't think I see it.
Our textbook is
It's not.
There's a Quizlet.
There's a what?
There's a Quizlet.
A Quizlet of our textbook? What does that mean?
Quizlet
Like all the
owns Slater.
answers have it. It's Quizlet owns Slater.
Like if you have Quizlet Plus, you can get two.
These are a lot of words I don't recognize. So, is Quizlet? Quizlet's like a game, right? That's how I view it. Is it a game?
It's like a study.
Study tool. So,
But now you can like search every chapter, so it's like Slater tomorrow.
oh, so you know that.
They bought Slater. So it's basically true.
How do you want to fight? Because I did it right. I'm done. Yeah, you plug it to the X. Since you put it X dx, right? Yeah. They want to think over one operator is on over 2 do you want to be and you just give it derivatives and you end up not mattering. 1 over you want to be I don't know how to take a derivative of 1 2
Oops.
you like all of that. What is it? Yes.
Everybody get that far?
Yes.
Now, here's what you have to recognize. When I say what's the overarching template of this problem, like if you're putting a u in place of x squared minus 9, you're obviously having a fraction here. Like, but I don't know if it's going to be a power rule or 2ln or not 2ln. That is the question. Okay. So what is our placeholder? We have x dx turns into x dx turns into 1/2 du. 1/2 du. Yes? Now, could you put a 2 in the denominator? You could. How many of you called it 2u down there? You know who you are. Yes, that's fine. I'm fine with that. But you're going to have to play the game 2ln or not 2ln, which is a great opportunity. And I bet some of you did it on purpose to have an excuse to play the game. Were you here for the game? Kyle, I don't know if you, were you here? I don't think you were here for it. You watched the video, right?
Again. Of course I watched that.
I sent didn't I send a special message to someone?
Yes, you did.
I think I remember that.
You sent a special message?
Yes. So you watched it.
I'll have to
Thank
rewatch
you.
it.
Thank you for watching.
I'll have to rewatch it. Must have missed that part.
You couldn't have. I got up close and personal. I know Madison's listening right now. We should send Madison a special message. Everybody say hi, Madison.
Hi, Madison.
They miss you. All right. And I said, hi, Tyler. I said this. I forget what I said, but special. It was special. All right. So if you put the 1/2 out front, that's good. It's a good habit just to put any constants out front. All right. Now we have to insert a placeholder because the book will sometimes do this. Yeah, I thought some of you would say ew. I thought you would say ew. Did you say cancel these? I take back any message I sent to you.
I didn't say that. I said it.
Go back, watch the message. I still need it. Okay. All right. That is an ew though. I agree. It's an ew. It's an ew. I would rather have a placeholder of 1 up there, wouldn't you? That's an ugly one. I apologize. All right. Now don't forget your bounds. If you leave the bounds off, I will leave points off. So we run this through the conversion process. Beep, boop, beep. All right, plug in 0. What's 0 squared? -9. How about 2? What's 2 squared? -9. Ooh. Ooh. How many of you got this far? High fives. All right. Don't take the half five. All right. Here we go. Antiderivative time. 1/2 goes along for the ride. 2ln or not 2ln? ln. Absolute value u. Did you have that absolute value? Yes, yes. Next step, did you have the plus c? Yes, yes. From -9 to -5. If you didn't put the absolute value, you're going to run into issues in this problem. All right, equals 1/2 ln 5 plus c minus 1/2 ln 9 plus c. So I'm sure all of you got 1/2 ln of 5/9. Yes, yes. When you subtract logs, divide their arguments. Yes, yes. If you didn't write that, it's okay. It's okay. You don't have to correct it. If you put 1/2 ln 5 minus 1/2 ln 9, that's fine. That's fine. Arguments. They're arguments. ln of x. This is called the argument. No? Yes? No? Did I say your last name? That's a property of ln's. Cool.
Out of curiosity, is tangent x would the x be also an argument?
It's an argument. Yep, the argument of tangent.
For like radicals.
Mm-hmm. Yep. Last one. Don't look. Don't look. Hide your eyes. You're all looking. I said to hide your eyes. Okay, let's do this problem without knowing anything about it. Stop! These are the worst. I wonder how we'll do this one. Because if I let u equal sine of x, do you agree du would be cosine of x dx? Can I adjust for that cosine of x? Let's run through a typical student thought process. You would not have said trig identity, you liar. All right. Do you agree a common thought process would be to let u equal sine of x? Don't write this down. What's du? Good. Cosine of x dx. So what would I have? U cubed, but do you see how I don't have a cosine x dx? It's not a good substitution. I can't adjust with a cosine like I can for constants, can I? I can't just multiply both sides by 1 over cosine, can I? Are you legitimately asking? That's fine. Let's try. Ready? Divide by cosine x. So 1 over cosine of x. 1 over cosine x du equals dx. So this dx gets replaced with a... Here's what it would look like. It would be u cubed, and the dx would be 1 over cosine of x du. That's not good. I have u's and x's. I can't. I can adjust for constants. I can't adjust for functions, right? every time we turn like a 4 into an 8 or a 1/2 into a whatever, but we can't adjust for a cosine of x. You can't like, it's going to make it a whole different problem. Do you understand that? All right. Does anyone have any ideas on how to approach this one? Great. I'm glad Mr. Delap prepared you for this. Trigonidentities. Tridentities. So isn't this a sine squared x times a sine of x dx? Isn't it sine cubed? It's a sine squared times a sine. Now, if you're thinking, well, let u equal sine of x, and du would be cosine x. I don't have a cosine x dx. I don't know, there's sine of x dx. If only we had an identity for sine squared x. Maybe like 1 minus cosine squared x. And what if we let u equal cosine x? What would the du be? Negative sine of x dx. Ooh, that's a nice substitution. I can adjust for that negative. So we're going to let u equal cosine x. Du is negative sine of x dx. I don't have a negative sine of x dx, so I need to get that negative over to the other side. So my integrand now looks like this. 1 minus u, I said red, u squared, and then the sine of x dx turns into negative 1 du. And those parentheses they're necessary because of that negative 1, but the integral symbol kind of breaks it up as a separation of terms. So technically, I didn't need the parentheses in there. If I brought the negative 1 all the way out front, if I put it in the integrand, I would need to leave them there. And you could even distribute the negative 1 at this point. Would you guys want to do that? Do you want to distribute the negative 1? Let's do it. I have negative 1 plus u squared du. We're ready to anti-differentiate. Are you ready? I'm about to cringe, but let's do it anyway. What's the antiderivative of negative 1? Negative? U. Good, negative u. Not negative me. Negative u. Plus 1/3 u cubed. Plus c. Tyler won't forget that. Even though you did miss the problem on the test where it was like the derivative of the integral with the x up top.
I did. No, I did one backwards. It was like 6. It was like to the 6/5, and you have to or it's negative 6/5. I just added negative 1 to that.
Oh, added
negative 11/5.
Gotcha. All right. What did we let you equal? Cosine x. So we have negative cosine x plus 1/3 cosine cubed x plus a constant. Wasn't that a beautiful identity? It kind of reminds us to have our own identity, to be who you are. Don't just settle for a trig identity. Okay. Within every word trig, there's always try. Okay, and remind yourself, and whatever you do, try. With an I. Never mind. Doesn't work. Speaking of doesn't work. Are we gonna do this homework tonight, Tyler?
Am I like deciding? Like everybody?
There's always the decision, but remember, you can't spell trig without try.
Yeah, but so it's 3 questions.
I don't know if this is the right homework. Hold on a second. I had it typed out. 19, 22, 25, 26, 32,
Right there.
Yeah, it's
22, 25, 26, 32, 33, 35, 39, 40. Beautiful. And I'm even going to help you out with number 33. Any ideas? What shall we let you equal? Pull with the K.
ln to the 6th of x.
If we let you equal ln of x to the 6th du would be 6 ln x to the 5th dx. Do we have a 6 ln x to the 5th dx? Well, this would all be u. Agree? If we let u equal ln of x to the 6th, this whole numerator would be u. Do we have a 1 over x dx in our du? No. So let's go back, try something else. Remember. If at first you don't succeed. TRI, again. Okay? Try again. Have you heard that quote? If at first you don't succeed, try again. And you can't spell trig without. So what should we try this time? ln of x. Let's try ln of x. Let u equal ln x. What's du? What's the derivative of ln x? 1 over x dx. Let's see. Isn't ln of x to ln 6th x really ln of x to the 6th? So our numerator says u to the 6th, and isn't 1 over x dx turning into du? Is that accurate or not? It is. And that is an easy antiderivative. Have a wonderful Tuesday. I know there's quite a few problems up here, but trust me, you need to do as many as you can. Try your hardest.
I don't believe my dad.